Hello dear students, so welcome back to physics online class. So we were in the discussion of Kirchhoff laws. So in that Kirchhoff laws, so by taking use of that Kirchhoff laws, so we derived that expression for that balancing condition for Wheatstone bridge network. And that previous session, so we discussed about that cells are connected in series combination and cells are connected in parallel combination. So just to recall the formulas for that relation between current, EMF and external resistance. So about the terminal potential difference and about that internal resistance of a cell. Then cells are connected in series combination. What about its equivalent EMF and what about its equivalent internal resistance and current through the external resistance, in which case it is maximum, and the same scenario in case of that parallel combination of the cell. So in today's session, so let me focus on some numericals related to cells as well as a balancing condition for Wheatstone bridge network. So let me look at some numericals on cells here. So just I will read out the question here. A 50 volt battery is connected across a 10 ohm resistor. So one battery is there, so that battery voltage is 50, so that is EMF of the cell. So what its value? That is 50 volt. It is connected to a resistance and its value is 10 ohm. So resistance of that resistor is 10 ohm. The current is 4.5 ampere is flowing through the resistor here. So how much amount of current is flowing through the resistor here? 4.5 ampere of current is flowing through the resistor. Then internal resistance of the battery is, so which thing I need to determine here? Internal resistance of the battery. So what is the connecting formula here? So the given question is like so. So for example, here one cell is there. Okay, so that cell having that EMF 50 volt here, that cell having internal resistance here, so that value I want to find out here, and this cell is connected to an external resistance here, and that external resistance value is 10 ohm here. And so how much amount of current is flowing through this resistance? So that is 4.5 ampere. So they asked to find out that what is that value of internal resistance of this particular cell here. So what is the connecting formula? So current they mention, external resistance, internal resistance and R. What is the connecting formula I have? So just recall the formula. I is equal to what? E divided by R plus of R here. So just I will rearrange here. So R plus of R is equal to what? So E by I here. Just fill the value. External resistance value is 10 ohm, internal resistance value is yet to be determined. EMF of the cell is 50 volt and current is 4.5, or just I can take that 45 into 10 to the power of minus 1. 5 times answer here. So just simplify that. 10 plus of R, so where small r represents that internal resistance of a cell, so that is 10 divided by 9 into 10 to the power of minus 1. If it goes to numerator, so that is 10 to the power of 1, so that is 10 here, so 9, so 100 by 9, so that is 10 plus of R. If it goes to right side, 100 by 9 minus of 10 here, so just simplify this one, 100, so make that multiplication here, divided by 9. So internal resistance of the cell, so that is 10 by 9 ohm here. What is that internal resistance of the cell here? So 10 by 9 or 9 ones are, so 1 remains, means that is 1.1 ohm here. What is that internal resistance of the cell here? Internal resistance of the cell is 1.1 ohm. So we'll look at next one. A cell whose EMF is 2 volt and internal resistance is 0.1 ohm. So one cell is there, so that cell having that EMF, so that EMF is 2 volt. So EMF of the cell is 2 volt and that has internal resistance, that value is 0.1 ohm here, connected with a resistance of 3.9 ohm, then voltage across the cell will be, so they mentioned that external resistance value is 3.9 ohm. Then they asked to find out that voltage value, means terminal potential difference value is yet to be determined here. So what's the connecting formula? So just I will take that V is equal to I into R from that Ohm's law. What's the relation between current, EMF and external resistance? Shall I use this formula? So V is equal to I means E divided by R plus of R. So here R term is there. So just take the value. EMF is 2 volt. External resistance value is 3.9. 3.9 plus of internal resistance value is 0.1. So V is equal to 2 into 3.9 divide by 4 here. So 2 ones are 0.95. So V value is how much? 1.95 volt here. What is? So we'll look at next one. The EMF of a Daniel cell is 1.08 volt when terminals of the cells are connected to a resistance of 3 ohms. So one cell is there, that cell having that EMF 1.08 volt here. So EMF of the cell is 1.08 volt and the terminal is connected to a resistance, so its value is 3 ohm. Then potential difference across the terminal is to be find out 0.6 volt. That is terminal potential difference is 0.6 volt. Find the internal resistance of the cell. So which thing I need to find out here? Internal resistance of the cell. What's the connecting formula I am having for internal resistance of the cell? So shall I use this equation? So E minus of V or E by V minus of 1 into R. So this is the standard formula. So we derived in previous session. So just to go back if you are not getting this formula. So E by V minus of 1. EMF of the cell is 1.08 whereas terminal potential difference is 0.6 minus of 1 and external resistance of the wire or external resistance is 3 ohm. So 1.08 minus of 0.6 here. So 1.08 minus of 0.6 divide by 0.6 here. Just will make the simplification. You will get that internal resistance of the cell. So 1.08 minus of 0.6. So that is 0.48 divided by 0.6 into 3. 6 1 the 6 8. So that is 0.8 here. 6 1 the 6 8 the 48. So 0.8 into 3. So that is 8 into 3 is 24. So 0.8 means 0.24 ohm. What is the internal resistance value? 0.24 ohm here. Next we'll look at next question. A primary cell has an EMF of 1.5 volts. So one primary cell is there. It is having that EMF 1.5 volt. When short circuited, it gives a current of 3 amp. So what's the mean of short circuit here? For short circuit, external resistance value is 0. So remember the 1 point. So for short circuit, external resistance value is 0. It gives a current of 3 amp when the internal resistance of the cell is. So then after short circuiting, it produces a current in the circuit is 3 ampere. Then what about that internal resistance? So we'll use that same equation. I is equal to E divided by R plus of R. For short circuit cell, external resistance value is 0. Then I is equal to E by R. R is equal to what? E by I here. So EMF of the cell is what? 1.5. Current is 3 here. So that is 0.5. So what is the internal resistance of the cell here? Internal resistance of the cell is 0.5 ohm. So next one. If the external resistance is equal to internal resistance of a cell of EMF E. So external resistance is equal to internal resistance here. So external resistance is equal to internal resistance of the cell. Then potential difference across its terminal is, which thing I need to find out here? If external resistance is equal to internal resistance, then what about the potential difference? Means terminal potential difference across the cell. So I am having connecting formula. So V is equal to E minus of I into R here. So if external resistance is equal to internal resistance means V is equal to, shall I take it as I into R? E minus of external resistance is equal to internal resistance means smaller, also I can take it as capital R here, minus IR if it comes here. So that is plus IR. IR plus of IR, it is equal to E. 2 times of IR, it is equal to E. Product of IR, shall I take it as a V here? So from Ohm's law, 2V is equal to E. V is equal to what? E by 2. So what it means here? If external resistance is equal to internal resistance of the cell, then terminal potential difference is half of the EMF. So when the terminal potential difference is half of the EMF, when that external resistance is equal to internal resistance of the cell. Next one, 4 cells each of EMF 2 volts. So how many number of cells? Number of cells are 4 they mentioned. 4 cells each of EMF 2 volt here. So each cell having that EMF 2 volt and internal resistance is 1 ohm. So what about that internal resistance here? Internal resistance is 1 ohm. Internal resistance is 1 ohm connected in parallel with an external resistance of 6 ohm. So these cells are connected in parallel with an external resistance of 6 ohm. Then current in the external resistance is, so which thing I need to find out here? Current in the external resistance. So look at here. So nature of combination is parallel here. In case of parallel combination, so EMF will be remain same, so it won't get changed here. So R plus of internal resistance, shall I take it as R by N here? So just I recall the formula, or you can take it as direct formula, E divided by R into N plus of R whole by N. So this is the formula. So what is the connecting formula for that N number of cells are connected in parallel combination? This is the required formula. From this formula I can able to calculate that current through the circuit here. 4 into each cell having that EMF 2 volt, external resistance value is 6 and the number of cells are 4 plus internal resistance value is 1 ohm here. 8 divided by 25 here. 8 divided by 25 amp. 6 point something here. So 6 point something is 2 on the page. So that is our, so 0.3 something. So that is 0.32. So what's the answer here? 0.32 ampere. What is that current in the external resistance? Current in the external resistance is 0.32 ampere here. So I hope you are following these things. So just to recall the formula, so just to dictate the notes, whatever the assignment or whatever the PDF file I sent to you. So then you go through the formulas, then only you can able to solve that numericals. So it's the biggest chapter. If you are having grip on this chapter, so half of the work is done. Okay. A student is asked to connect 4 cells of EMF 1 volt here. How many number of cells here? So I given 4 cells. So each cell having that EMF 1 volt. So number of cells are 4. Each cell having that EMF 1 volt. And internal resistance is 0.5 ohm. So what is the internal resistance of that cell here? 0.5 ohm in series with an external resistance of 1 ohm. All these resistance are connected in series combination with an external resistance 1 ohm. But one cell is wrongly connected by him with its terminal is reversed. Current in the circuit is, so out of 4 cells, 1 cell it is connected in a wrong way. Number of cells are connected in wrong way is 1 here. Then what about the current I need to find out? First I have to find out that what is the equivalent EMF when you connect that cells in a wrong manner. Equivalent EMF in case of that wrongly connected cells, N minus of 2M into E. Did you remember this formula? Number of cells are 4. 2 into 1 cell is wrongly connected. M indicates that number of cells are connected in a wrong way. Each cell having that EMF 1 volt. So equivalent EMF, so that is 2 volt. What is that equivalent EMF? If that one cell is wrongly connected, so that is 2 volt here. Then I can find out that current through the circuit. I is equal to E equivalent divided by R plus of R equivalent. In case of series combination of the cell, what is the connecting formula for internal resistance? If n number of cells are connected here, R equivalent is equal to n into R. So I will use that same formula here. I is equal to equivalent EMF is 2 volt, I get it, divide by external resistance value is 1 ohm and internal resistance value is 0.5. How many number of cells? So 4 cells here. Number of cells are 4, each cell having that EMF 0.5 or 1 by 2 you can take. 2 divided by 2 by 3 amp. So what's the current in the circuit here? Current in the circuit is 2 by 3 ampere. Next one, 12 cells, each of EMF 2 volts. So how many number of cells here? Number of cells are 12, each having that EMF 2 volt, are connected in series. Among them 3 cells are wrongly connected. Number of cells are 12. Out of 12 cells, 3 cells are wrongly connected. M means number of cells are connected in wrong way. Then effective EMF of the combination. So same formula. What's the formula? E equivalent is equal to n minus of 2m into E here. In wrongly connected cell, number of cells are 12 here. Out of 12, 3 cells were wrongly connected, each cell having that EMF 2 volt. Then equivalent EMF is 12 minus of 6 into 2 here. Equivalent EMF is, so that is 12 volt. What is the equivalent EMF here? Equivalent EMF is 12 volt. Next one, 2 cells of EMF 1.25 volt and 0.75 volt. So 2 cells are there. These 2 cells having that respective EMF 1.25 and 0.75 volt. Each of internal resistance 1 ohm are connected in parallel. Then effective voltage will be. So which thing I need to find out here? Effective voltage. 2 cells here. E1 value is 1.25 volt. E2 value is 0.75 volt. 0.75 volt. Each cell having internal resistance 1 ohm. R1 is also 1 ohm. R2 is also 1 ohm here. R2 is also 1 ohm. Internal resistance is same for both the cells. These 2 cells are connected in parallel combination. Effective voltage will be. What is that equation for effective EMF when the 2 or more cells are connected in parallel combination? Did you remember that formula? E1 into R2 plus of E2 into R1 divide by R1 plus of R2. E1 is how much? 1.25. Internal resistance is 1 ohm for both the cell. 0.75 into 1 divide by 1 plus of 1. Equivalent EMF will be, so 1.25 plus of 0.75 divide by 2 here. So 2 by 2, so that is 1 volt. What is that equivalent EMF here? Equivalent EMF is equal to 1 volt. If the identical cells each having EMF 20 volt, identical cells are there, identical cells having that magnitude of the EMF is 20 volt are connected in parallel, then effective EMF of the combination is. So look at the question carefully. So number of cells are there, each cells having that EMF 20 volt. So what is that EMF of each cell here? Each cell having that EMF 20 volt. These cells are connected in parallel combination. So they asked to find out that what is the equivalent EMF in that combination. So in case of parallel combination, EMF will be remain same. One cell will produce the EMF 20 volt means, so all cell also produce that same EMF. In case of parallel combination, EMF is remains same. EMF is remains same. So that is each cell having 20 volt means all cell also having that same 20 volt EMF when you connect in parallel combination. Okay, next we'll look at that. Okay, so we'll solve the next question. When a battery connected across a resistor of 16 ohm, so one battery is there, so that battery is connected across a 16 ohm resistor, so that resistance value is 16 ohm. Voltage across the resistor is 12 volts. So if you connect that battery to a 16 ohm resistor, its potential difference will be 12 volt here. What's the potential difference? I will get it here, 12 volt. When the same battery connected across the resistor of 10 ohm, the same battery, so initially I will connect to 16 ohm resistor, the same battery again I will connect to that of 10 ohm resistor, the potential difference will be 11 volt. So for 16 ohm, terminal potential difference is 12 volt. For the 10 ohm, terminal potential difference will be 11 volt here. Then internal resistance of the battery in ohm is, so which thing I need to find out here? Internal resistance. They mention that the same battery means, shall I take this E1 as E1 is equal to E2 here? It means that first cell and second cell, the same cell they mention. From that general formula, V is equal to E minus of I into R. So minus I into R I will take into left side. V plus of IR is equal to what? E. E1 and E2 are same, means instead of E, shall I take it as V plus of IR here? Here V means terminal potential difference across the first cell, current across the first cell, or internal resistance is same. Same cell means internal resistance will be same only. V2 plus of I2 into R. So just I will solve the value of R here. So V1 is how much? 16 plus of, look at here, instead of I1, shall I take this one from Ohm's law? I1 is nothing but what? V1 by R1 here. Here I2 value is nothing but V2 by R of 2. I will take it here. V1 is 12, R1 is 16 here into R. V2 is how much? V2 is 11 and V2 by R2, 11 by 10 R here. So just solve that value of R here. Look at here, 16 plus of 3 R by 4, it is 12 here. 12 plus of 3 R by 4, it is equal to 11 plus of 11 by 10 R. So 11 means 11, if you take that left side, 12 minus of 11 plus 3 R by 4, if it goes to right side, 11 by 10 R minus of 3 by 4 R here. If you take that LCM, so 10 and 4, if you take that LCM, it becomes 20 here. So multiply by 2, so 11 into 2, 22 R minus of 5, so that is 15 R here. Look at here, 20 is equal to 22 R minus of 15 R, so that is 7 R. R is equal to 20 by 7. So what is that internal resistance of that given cell here? Internal resistance of the given cell is 20 by 7 R here. So now related to Kirchhoff law, so we'll solve some numericals. So some simple circuit is there. From the simple circuit only we can able to find out that current, resistance value and as well as internal resistance value of that given circuit we can able to find out by that Kirchhoff rules here. The value of current I in the given means the value of current I in the figure as shown will be, so in that given diagram I want to find out that value of I here. So let me draw on that diagram. So here 10 they mention 10 amp, here 6 amp they mention, here 1 amp they mention, and here 2 amp they mention. And what's the value of I need to find out here. So which thing I need to find out here? Value of I. So look at here, 10 ampere of current. So from that KCL, sum of entering current is equal to leaving current. Which is entering current? 10 ampere is the entering current. What are the leaving current here? So here 6 amp of current is flowing here. Then what about the remaining current must flow here? So 10 ampere is entering means 10 ampere will get leave. So here 6 ampere means, so remaining current is 4 ampere is flowing in that another wire. So look at here, this 4 ampere is comes to that point A here. Out of 4 ampere, if 1 ampere of current is moving upward means how many ampere of current will comes to this point? So that is 3 amp. Entering current is 4. So leaving current is also 4 only. Already 1 ampere is moving in this wire means remaining current will comes to this wire only. So look at here. Here 3 amp. Entering current is 3 amp. So in this branch what will be the entering current? Look at here. 6 ampere is here. 2 ampere is here. So what are the entering current? 6 and 2. Then what must be the leaving current? Here that is 8 ampere of current. 3 ampere of current and 8 ampere of current is entering here. So sum of entering current is equal to leaving current. Sum of entering current 8 plus of 3. So that is 11 ampere of current is present in the branch here. So what is the amount of current is present in the branch? So in that branch 11 ampere of current is present. So 56, 11 ampere of current is present. Next one, find E for the given loop. So they mention one loop here. Or look at here. So another example I will take related to same KCL only. Electric current I in the given circuit is, the given one circuit. So I have to find out that electric current in the given circuit. Okay, so they mention the value here. Here 1 ampere, here 2 ampere, here 1 ampere, here 2 ampere, here what is the amount of current in this branch? What is the amount of current I need to find out here? So look at here, for that purpose 1 ampere is entering, 2 ampere is entering, so total how much amount of current is entering here? So that is 3 ampere of current. Out of 3 ampere of current, 1 ampere is goes like this. So how many ampere will be it remains here? That is 2 ampere will remain here. 2 ampere is moving here. 2 ampere is moving here. How many amps of current will get enter here? 4 amps of current. Then I value is how much? 4 ampere. So this is about KCL law.